Hello everyone. In this demo, I present ML2++, a model-driven framework for building IoT application with integrated time series forecasting. I will show two editors, a quick start textual editor and a graphical editor based on Serious Web. The main objective is end-to-end automation, modeling, code generation, executions, and visualization. The example is a time series forecasting workflow integrated into an IoT-style component architecture. On the screen, the left panel is the textual models, and the right side provides output views. The button's action include save, generate code, run code, and plot options for preprocessing and forecasting. I begin by describing the IoT architectures in a river flow forecasting example with three key components: sensor client, flow server, and flow analytics. The sensor client is responsible for sending sensor message containing future value. The flow servers act as a mediator forwarding message and coordinating request. The flow analytics components embeds the ML pipeline and produce forecasts used by runtime logic. This is important. ML2++ link analytics executions directly to components behavior. Next, I define the data analytics specification include data preprocessing, time series forecastings, evaluations, and model setting. In the model block, I define the time series models. In this demo, I selected an NLP models. Next, I define evaluation metrics such as MSC and RMSC to quantify forecasting error. Now I run the pipelines from the interface. The tool generates scripts for preprocessing, training, and predictions, and executes them. The console output display training progress, including epoch level loss. This confirms that the code generations and executions are working end-to-end. After executions, the system produces artifacts such as logs, plots, and predictions file. I now inspect the result and related them back to the model configurations. This closes the loop between modeling choices and empirical outcomes. And now you can see all of forecasting plots here. Now I open Serious Web to start modeling visually. You can see Explorer on the left, central canvas, and a detail panel on the right. Now I start adding the main components of systems. I begin adding the core things that forms the IoT architecture. In this example, we use a sensor client, a flow server, and the flow analytic components. I place the blocks on the canvas so the structure is clear and readable. Now I continue wiring connections between things. The goal is to connect sensor client to flow server and flow analytics using messages such as sensor data, query, ACK, alert. Next, I focus on the flow analytics service interface. I added the file service port, which is an entry point for analytic request and result. Next, I select the data analytic element to configure the pipeline. With data analytics selected, the details panel show configurations field. This field includes dataset label, timestamp, threshold, preprocessing switch. I explained that the configurations drives the generated Python script. Next, I open the dedicated forms view for easier editing. I open the form view for the data analytic configurations. This form is organized into tabs: data preprocessing, time series, model evaluations, and visualizations. I navigate to the preprocessing tab to set transformations. Now I select concrete preprocessing options. So in preprocessing, I choose how raw data will be prepared. This includes future scaling, sample normalizations, missing value handling, and so on. After completing configurations and modeling, we move to executions in Orchestrator. We will download the rebel.xml. Then we upload the XML files in the Orchestrator. And also we upload the dataset. Now you will see the project generation and executions outputs. I point to the dataset upload area that lets you attach the input. Next, I show what appears after executions, download report. Now I show the generate console output. Finally, I open the image and report. At the end, we can download and inspect the produced artifact.